Excuse my bushy face, it's COVID-19 lockdown and I can't access my barber. But again, I can't wait for lockdown to get done for me to record this. So let's get to it. There are some numbers that cannot be represented accurately in fraction or decimal form. If we attempt to express them in decimal form, we shall often end up with rounding errors. Here's a case in point. We have square root of 3 and that whole square root of 3 is in brackets and it is all squared. We can calculate it like this. We can punch square root of 3 into a calculator and that will give us a very long number which we can round off to 3 decimal places to have 1.732. Then we get the 1.732 and square it again and our answer will be 2.99824. We can also calculate it directly. Square root of 3 will give us the answer 3 directly. From the two scenarios above, you notice that the first answer has an error that came about because of rounding off. To avoid such errors, it's better we do not convert the number to decimal form, but rather we leave it in its square root form. Now this square root form, okay, I'm just calling it square root form, but actually the more accurate word would be leaving it in its surd form. So when numbers are represented like that, and they are left as square root of 3, square root of 2, that is what we call surds. And in our illustration, it shows that surds are more accurate. In real life, professionals like engineers who are building bridges require that their calculations are accurate and precise. And in order to achieve this, they always use surds in their calculations. In other words, surds are used where accuracy is required in calculations. My name is Arnold Rangakuramya and in today's lecture we are discussing surds. Today we get to look at surds. This is Kisembo Academy. Thanks for tuning in. Now, before looking into surds, we need to understand the difference between rational and irrational numbers. Now, to begin with, rational numbers are those which can be expressed in the form of P over Q. Now, P and Q are integers, as long as none of them is 0. And examples of integer numbers here we have 1 over 3, 36 over 1, 2.05 is equal to 205 over 100, and so on. Now these are rational numbers. Now the opposite of these are numbers that are irrational, and irrational numbers are simply those that cannot be expressed in this form. They cannot be expressed in form of fractions. In other words, irrational numbers are numbers that can't be expressed in fractional form. And some of these are shown here. We have the square root of 2, which is that, the square root of 3, which is that number, the third root of 70, which is that. Now looking at these numbers, there's something we see about them, that they are infinite and non-recurring decimals. Now, because they are infinite and some are non-recurring decimals, some are infinite, it becomes hard for you to easily locate the square root of 2 just like that, unless you use a calculator. So numbers such as square roots, cube roots, which cannot be evaluated exactly, are better off left in this form, as you can see. So now numbers that are left in this form because you cannot easily evaluate them are what we call surds. So this form is what we are calling the surds. Or in other words, I can say that a surd is any number of this form, of the square root of a, of square root of b, where a and b are any integer. So a surd is any number of that form which cannot be expressed as a rational number. So we are going to go on and look at how we simplify surds. In simplifying surds, we need to know some background knowledge about surds. In this illustration, in black ink, we have the square root of 4, multiply that by the square root of 16. We know that the square root of 4 is 2. The square root of 16 is 4. So 2 times 4 gives us 8. But at the same time, a square root of 4 times 16, if you first find the square root, you first find the product of these two numbers, which is 64. And you go ahead and find the square root of the product of those two numbers, it's still going to give you the same answer, which is 8. So it is either way, so this means, see, since when we found the square root of 4 separately and then the square root of 6, it gave us 8, and then we first multiplied these two again to get one number, then we still got the same number of 8. It simply means that square root of 4 multiply that by square root of 16 is the same as square root of 64. And this kind of analysis brings us to a conclusion as this. The conclusion it brings us to is that square root of A times square root of B is the same as square root of A times B combined. We need to commit this to memory. Also, we get to look at another illustration here. We are having 4. Square root of 4 multiply that by square root of 4 gives us the square root of 16. And when we find the square root of 16, our answer is 4. We were dealing with the same figure and it gave us square root of 4. Likewise, square root of 5 multiply that by square root of 5 gave us square root of 25, and we know that the square root of 25 is 5. So when we multiplied the square root of the same number twice, we got the same number. So this also brings us to another conclusion. For example, if I have square root of 100 times square root of 100, the answer I expect here is 100. If I'm having the square root of 20, multiply that by the square root of 20, I should be able to get 20 as the answer. If I'm having the square root of 1,000, multiply that by the square root of 1,000, it brings us the answer to 1,000. This is the conclusion these two illustrations bring us. And in general terms, square root of x multiply that by square root of x should be able to give us the answer as x. So with that brief background information, now let's get on to simplifying these surds. Now in the simplification of these surds, in most cases we are always given an entire surd, like such as this one, root of 24. And we are supposed to simplify this square root of 24. Now, in the process of simplification of this square root of 24, we need to first split this number into its factors. Now, one of the factors that we choose, because now if you look at this 24, we have factors such as 2 times 12. 2 times 12 gives us 24. Then we have 3 times 8 can give us 24. Then we have 4 times 6. It can still give us also 24. So we choose 2 factors, but one of those factors should be able to give us a direct square root that is known. So in this case, 24 is going to, when we choose 4 and 6, 4 times 6 gives us 24, we find that we can easily get the square root of 4, which is 2. So square root of 4 times 6 means it's going to be the square root of 4 times the square root of 6. Now, of course, we know the square root of 4 can easily be gotten. It is 2. But we do not know the square root of 6. It is an irrational number, so we leave it in surd form. So it means that our final answer is going to be 2 times the square root of 6. Now this 2 times the square root of 6 is what we are calling a mixed surd. Why are we calling it a mixed surd? Because it is a product of a rational number and an irrational number. So in other words, a mixed surd is a product of a rational number and a surd. So we always convert an entire surd to make a mixed surd in the process of simplifying surds. And this is something that we shall always encounter a lot in our calculations. So we'll go straight ahead and try and simplify some surds for illustration purposes. Right here we are having the square root of 99. So to simplify that surd, we are supposed to identify 2 factors of 99, but one of those factors should be able to give us a direct square root. So here, this is the same as saying the square root of 9 times 11, because 9 times 11 is 99. But we know this is the same as the square root of 9 times the square root of 11. And we know the square root of 9 is 3, so it's 3 times the square root of 11, which is not a direct, cannot easily be gotten. So we leave this in surd form because we do not know it directly. We need to punch a calculation. It's an irrational number. So the final answer is going to be here 3 root of 11. And this is the simplification of that entire surd. This is what we're calling a mixed surd. Going on to our second example, square root of 50 is going to be the square root of 2 times 25. That's going to be, this is the same as the square root of 2 times the square root of 25. And of course, the square root of 2 is an irrational number, so we leave this in surd form as square root of 2. Multiply that by the square root of 25, which is known, which is 5. So the answer here is going to be 5 times the square root of 2. So 5 root 2 becomes our mixed surd, and it is the simplification of this entire surd. To continue to simplify these surds, if you look at this, we have 4 times the square root of 72. Now, this looks like it is a simplified surd, but it is actually not, because why? The number under the square root sign can still be simplified further. When we are simplifying surds, we are supposed to do it in such a way that the number under the square root sign cannot be simplified any further. So, in other words, a surd is said to be in its simplest form when the numbers under the square root sign have no perfect square. And of course, we all know the perfect squares we are talking about. We have like 1 is a perfect square because 1 squared is 1. We have 4 is a perfect square because 2 times 2 is 4. We have 9, which is a perfect square because 3 times 3 is 9. We have 16, we have 25. All those are perfect squares. So we are supposed to simplify a number to a point whereby the number under the square root sign is not a perfect square. So 72 still can be simplified further. So to simplify this is going to be 4 times, this is going to be the square root of, now for 72 can be simplified further into 36 times 2. And so this is going to become 44 times square root of 36 times square root of 2. So you realize that square root of 36 is 6. So it's going to be 4 times 6 times the square root of 2. And 4 6 are 24. So it's going to become 24 times root 2. And now this is the simplified form of that surd. 75x squared is going to become the square root of 75 times the square root of x squared. And of course here, square root of x squared, this square root goes with that, you remain with x times the square root of 75. That's the simplification of that surd. Then we have 2 more numbers right here. We have 90a squared b squared. To simplify that surd, we look for factors of 90. Which of the factors of 90 have a perfect square? We can have 2 times 45, we have 3 times 30, we have 5 times, we have 9 times 10, and 9 is a perfect square, so we are going to choose this and replace it with that. So this is the same as saying it's going to be the square root of 9 times 10, that's going to be times a squared times, now b to the power 5. Now b to the power 5 is the same as b squared times b squared times b, like that. Let me rewrite this here. So now this is definitely the same as the square root of 9 times the square root of 10 times the square root of a squared times the square root of b squared times the square root of b squared times the square root of b. So this becomes, now the square root of 9 is 3 times the square root of 10 remains as the root of 10 times a squared, which is the square root of a, times b squared, which is the square root of b, times b squared, which is the square root of b, the square root of b squared, which is b, then times the root of b. So this is going to be b, 3 times a times b, which is going to become 3ab squared times the square root of 10 times b, which is 10b. And that is the simplified form of this. So let's do this. 243. Let's find the factors of 243. Now the factors of 243, we have 3 times 81 to represent this. So this we take on these 2 factors. So we know that 243 is the same as 3 times 81. Now this is the same as the square root of 3 times the square root of 81. But we know that the square root of 3 is an irrational number, so we leave it as a surd. multiply that by the square root of 81, which is 9. So it means that here our answer is 9 times the root of 3. And that is the simplification of that surd. So throughout our calculations, as far as surds are concerned, we shall always be required to simplify them, converting entire surds into mixed surds. Today we get to dig deeper into operations with surds. This is Kisembo Academy, and thanks for tuning in. But before we get deeper into operation with surds, we need to distinguish between what we mean by like surds and unlike surds. Now, when we were doing algebra, this is like saying like terms and unlike terms. So also here we have what we call like surds and unlike surds. And here we distinguish them from what we call the radicand. The radicand is this, the number we leave in the surd form in our simplification of surds. So here, these radicands, when they are the same, when you're having surds that are having the same radicand, these qualify to be called like surds. It's like in algebra when you're having x, then 2x, then 4x, then 9x. Because they're having the same unknown, they qualify to be called like terms. Now, of course, the unlike surds is the opposite of like surds. For unlike surds, they are simply numbers, or they are surds that are not having the same radicand. And if you can see here, this is having root 2, root 7, root 11, root y. So these are unlike terms, these are like terms. Now when we are adding and subtracting surds, we are going to make our additions and subtractions based on this radicand. Of course, before you add any two surds, they must be like terms. An illustration on how we add and subtract surds. In our first number, we have 2 root 6 plus 6 root 6. And we are saying we use the distributive property. We are having root 6 as the common term here, which is the like term. We put it outside the brackets, and in the brackets we are having 2 plus 6. And that's how we are ending up with 8 root of 6. Likewise here, we are having root 3 as the radicand. So we put this root 3 outside the brackets, and we are having negative 4, which is right there, and 5. It's more like factorizing up. And of course, negative 4 plus 5, you're getting negative 1 root 3. Now when we are adding surds, if it were algebra, this root 6 is more like x. 2 root 6 is like 2x plus 6x is going to give you 8x. Negative 4x plus 5x is going to give you negative 1x. As simple as that. So you can as well treat them like in that kind of algebraic way of looking at it. But when we are dealing with surds, we can only add and subtract surds that are like. And we say that like surds are surds that are having the same radicand. If you look at this, we are being required to simplify this. Now, this is a mixture of surds that are both like and unlike, as well as whole numbers as well. So what we do is that here in our first step, we collect like terms. We have 5, which is that one 5. 5 minus 4, so which is that one minus 4. Then we look at numbers with root 3, and we put them together. So we have plus 2 root 3, which is that one. Then plus 1 root 3, which is that one. Then we have numbers that are having root 5. Then we have plus 3 root 5, which is that one. Then minus 20 root 5, which is that one. Right there. So after arranging them like that, collecting like terms together, then you go ahead and simplify them. 5 minus 4 is 1. Then we have 2 root 3 plus 1 root 3 giving us 3 root 3. This is like saying 2x plus 1x, giving you 3 root 3x. So we have this also, the ones with root 5 and root 5. So this is like saying plus 3y minus 20y. Of course, plus 3y minus 20y, it's going to give us positive 3 minus 20 is going to give us 17. Minus 17 times the square root of 5. And definitely we can't solve this any further than this, and that gives us our answer. Now another person would do it like this. From this step, would come and do it like this. This is 5 minus 1, which is 1. Plus, now we have root 3 here, we have root 3 here. So he says plus 2 plus 1 in brackets root 3. He leaves root 3 outside the brackets. Then he comes to this. it becomes plus, in brackets he puts it's 3 minus 20, 3 minus 20, and he puts the root 5 outside the bracket. And of course you'll get the same answer, it will become 1. You'd still get the same answer. So we'll go ahead and evaluate them. So in numbers like these, we are supposed to first of all, the surds we are supposed to deal with are supposed to be simplified to their simplest form. If you look at 125 here, it is the same as saying 25 times 5. So this is 2 root 5, it's going to be 2 root 5 minus, under this square root, we can simplify this surd. It needs to be in the list. So this is going to be 25 times 5, then plus 180, that is, can be simplified further. And of course 180 is the same as 36 times 5. So this is going to be 2 times the square root of 5 minus root of 25 times root of, this is the same as root of 25 times the square root of 5 plus, this is going to become the root of 36 times the root of 5. Now you notice that in these factors here, the factors we chose to simplify this 125, this was 25 times 5. The factors we used to expand this number is 36 times 5. We chose on these ones because if you look, 25 is a perfect square, 36 is a perfect square. That is why we chose them. So when we are simplifying these sides, just like before, we are supposed to make sure that we choose two numbers of which one of them should be a perfect square. Because from a perfect square, you can easily find the square root of a number that is a perfect square. So right here, this is going to become 2 times the root of 5 minus square root of 25. 25 is a perfect square, so square root of 25 is 5 times root 5. Then this is going to become plus 36. The square root of 36 is 6 times root 5, which is that. So we end up with a statement that we are having 5 like terms, root 5, root 5, root 5. So what we do here is simply add. It's because all these are like terms. So it's going to become 2 minus 5, which is going to give us negative 3. Negative 3 plus 6 giving us positive 3. So it's going to give us 3 root 5. So this as well, to simplify this surd, first of all, again, our first step is to make sure that the surds we are dealing with are in their simplest form. So if you look at this, 80b can be simplified further, simplifying this surd. Likewise, 20a squared b can also be simplified further. So that's what we begin with. So this is going to become 4a into, now 80b is the same as 80b is the same as 16 times 5. 80 is the same as 16 times 5, then that is times b. Then we have, this is plus. Now the 20 here, 20 is the same as 4 times 5. 4 times 5, then times a squared times b. You realize that the numbers we've chosen here, 16 and 5, 16 is a perfect square. So we can easily find the square root of this, which is 4. Even here, 4 times 5 is giving us 24 is a perfect square. So we only choose factors where one of them is a perfect square. So after that step, this becomes 4a squared times the square root of 16 times the square root of 5 times the square root of b. That is plus the square root of 4 times the square root of 5 times the square root of a squared times the square root of b. So our next step here is going to be 4a squared times 16, root of 16 is 4, so it's 4 times the square root of 5 times the square root of b. Then we have plus square root of 4, which is 2 times the square root of 5. Now the square root of a squared, this goes with that, you remain with a times a, then times the square root of b. So this, simplifying this further, is going to give us 4 times 4, giving us 16 a squared. So it's going to be 16 a squared times the square root of 5b plus, this is going to become 2 times a, which is 2a times the square root of 5b. Okay, now this square is not supposed to be here. From this point, this is not supposed to be right there. There's an error. So we have 16a times root of 5b plus 2a root of 5b. So 16a plus 2a is going to be 18a times the square root of 5b. And that's the simplification of. Today we get to look at multiplication of surds. This is the Kisembo Academy, and thanks for tuning in. Now, it is as simple as what we've been doing before, that when we are multiplying surds, like for example root of a times root of b, it's the same as square root of a times b, which is square root of ab. An example here is that the square root of 2 times the square root of 5 is the same as square root of 5 times 2 combined, which is the same as the square root of 10. In our previous videos also we explored that when you're multiplying the same number, the same surd twice, for example the square root of a times the square root of a, you're bound to get that very number. If it's the square root of 100 times the square root of 100, you're bound to get 100. If it's the square root of 20 times the square root of 20, you're bound to get 20. And we illustrate it here using 4. That square root of 4 times square root of 4 is going to be the square root of 4 times 4, which is the square root of 16, which is 4. The square root of 4 is 2, times the square root of 4, which is also 2. 2 times 2 should give you 4. We explored some of these in our previous videos. And now from here we are going to build on to see how we multiply mixed surds. Remember we said that mixed surds are simply surds that are a product of a rational number and a surd. So let's look at how we multiply these mixed surds. This is a mixed surd because it's a product of a rational number and a surd. This is a rational number, that's a surd. So this is what we call a mixed surd. So when you're multiplying mixed surds, what we do, for example here we shall say that 2 times the square root of 5, multiply that by 6 times the square root of 2 is going to be equal to, we shall multiply the rational numbers together. So that's going to be 2 times 6, which is 12, times the square root of, then we multiply these together as well. That is 5 times 2, which is 10. So under the square root of 10. As simple as that. So this becomes our answer, 12 root 10. Now, the answer we get, of course, you're supposed to first evaluate to see if you can simplify it any further than this. So the answer we get should be in such a way that that is its simplest form. We can't simplify it any further than that. Let's try on this other. We have 4 times root of 2, then times 2 times root of 50. That's going to be equal to, so we shall multiply the whole numbers together first. 4 times 2 is 8, so it's going to be 8 times square root of 2 times 50, which is 100. But then now we realize that 100 can still be simplified further, the square root of 100. So that is going to be equal to 8 times the square root of 100, which is 10. So the answer here is 80. And that is the answer. Now that is how we multiply mixed surds. Now going on to use the distributive property, supposing we are having a surd that is outside the brackets and we are required to open brackets just like the way it is done in algebra. We shall do it in the same way. We are having root of b plus root of c inside the brackets and we are having root of a outside. So to open the brackets here, it's going to be root of a times root of b, then root of a times root of c, which is this step. Root of a times root of b plus root of a times root of c, and we shall end up with root of a times b plus root of a and c. We'll do an example still to illustrate this. Now in our illustrations we are being required to work this out. So square root of 3 into 3 root 2 plus 3 root 3 is going to be equal to, so we open brackets, square root of 3 times that, so this is going to become this times that, which is root 3 times 3 root 2 plus root 3 times this is going to be root 3 times 3 root 3, like that. So this is going to become now root 3 times 3 root 3. Remember this is 1 root 3 times 3 root 3. So we shall first multiply the whole numbers together. So 1 times root 3, 1 times 3 is 3. Then root 3 times 2 is 3 times 2 is 6, right? so it is root 6, then plus, then we have this is 1 root 3 times 3 root 3. So we first say 1 times 3, which is 3, then root 3 times root 3 is root 9. So definitely here it's going to become 3. Then now square root of root of 6 we do not know, so it's root 6 plus this is 3 times root of 9, which is 3 times 3. So our answer is going to be 3 root 6 plus 9, and this is our answer. We have one more number to illustrate this point. We are opening brackets here still. This times that, then this times that. So the next step from here is going to become 10 root 5, multiply that by this, 2 root 3. Then we have plus this times that. So it's going to be 10 root 5 times negative 3 root 2. Negative 3 root 2. Of course, we know that a positive times a negative will give us a negative answer here. So our next step here, when we're multiplying this by that, we are going to say it's 10 times 2. We multiply the whole numbers first. 10 times 2 is going to give us 20 under the square root of 5 times 3 is 15. Then, of course, here this will be minus because a positive and a negative should give us a negative answer here. So it is 10 times negative 3 is going to give us negative 30. So it's minus 30 under the square root of 5 times 2, which is 10. And if you look at this closely, I think we can't simplify this any further. So that becomes our answer. In this video, we are simply going to look at how we multiply binomials that are containing surds. This is Kisembo Academy, and thanks for tuning in. Going on straight to a worked example, we are having 2 plus root 3 plus 3 into 3 plus 2 root 3. We are multiplying these two brackets. So definitely, of course, we are going to open them. So this means that 2 plus the square root of 3 into 3 plus 2 times the square root of 3 is going to be equal to, we are going to multiply the bracket. So it's going to be 2 times this whole bracket, then plus root 3 times this whole bracket. So our next step here is going to be 2 times this whole bracket. We are opening brackets, so we are multiplying this bracket by that bracket. So it's 2 times that bracket, which is 3, plus 2 times the square root of 3, then plus root 3 into that whole bracket, which is 3 plus 2 root 3. So we go ahead and open brackets here. 2 times 3 is going to be 6. Then now this is 2 times 2 is going to give us 4 root 3. So it's going to be plus 4 root 3. Then we have here plus root 3 times 3. Root 3 times 3 is the same as 3 root 3 plus 3 root 3. Then root 3 times 2 root 3. Now definitely here it is going to become plus 2 square root of 3 times 3 is 9. Now you should take this as x. If this was algebra, it would just be like 2 times 3 is 6. Then we have this is 2 times 2x. 2 times 2x is going to give us 4x. Then here we'll have 3 times x, which is 3x. Then this would be like x times 2x. This will give us 2x squared. And definitely 2x squared. So in other words, these root 3, these numbers, these surds are the ones that I'm taking as the unknown x. So we continue by saying that this is going to become 6. Then definitely 4 root 3 plus 3 root 3. These are having the same radical, so they are like terms, so you can add them. This is 4 plus 3. This is going to give you 7 root 3. Then plus 2 times root of 9. Of course, root of 9 is 3. So it's 2 times 3. So you end up with 6. 2 times 3 is 6. So it's going to be 6 plus this 6. 6 plus 6, which is 12 plus 7 root 3. And going on to the next we are still going to do the same as before. This is going to become 7 outside the brackets times this whole bracket, which is 4, minus 3 times root of 5, then plus root of 5 into this whole bracket, which is 4 minus 3 times the square root of 5. Again, we are going to go ahead and open bracket. 7 times 4 is going to be 28. Then now 7 times negative 3 root 5. So the whole number 7 and 3 multiply itself, and you're going to get minus 21 times root of 5. Then we have root of 5 times 4 is going to give us plus 4 root 5. Then we have root 5 times negative 3. Definitely this negative and that positive is going to give us a negative 3 times root of course 5 times 5, which is 25, and the answer here is 5. So this becomes 28 minus, now this is negative 21, root of 5 and root of 5 is like negative 21x plus 4x, and definitely there our answer will be minus 17 root 5. Then this is minus 3 times root of 25 is 5. So this is going to become 28 minus 17 times the square root of 5. This is 3 times 5, which is minus 15. 28 minus 15 gives us 13 minus 17 times the square root of 5. And that is how we simplify that number. Okay, so now we go ahead and do this number. We open brackets. This is going to become 8 into 8 plus the square root of 3. Then minus root 3 times the square root times that whole bracket into 8 plus root of 3. So the open brackets, 8 times 8 is 64. 8 times that is plus 8 root 3. Negative 3 times that is going to give us negative 8 root 3. The negative root 3 times positive root 3 is still going to give us negative root 3 times 3, which is 9. And of course this is going to give us, this is going to die with that. We shall remain with 64 minus square root of 9. The square root of 9 is 3. And definitely 64 minus 3 leaves us with 61. Now, if you look at our last example here, it is more like difference of two squares. You remember this identity? If you look at this identity, it's more like this: a minus b into a plus b, which is a minus b into a plus b. And this a minus b into a plus b is giving us a squared minus b squared. If you look at this, a squared here is 64, which is that one, minus b squared, which is root 3 squared, which is giving us 3, which directly gave us 61. Now, this kind of concept is what is going to bring us to conjugate surds. And as we're dealing with conjugate surds, we shall be dealing with rationalizing. We shall be preparing ourselves to know or to learn how to rationalize the denominator. Conjugate surds, these are simply surds that are having a difference of either a plus or a minus in between them. In our example, in our illustration on our screen, we are having b root of b plus c. The square root of b plus the square root of c and b minus root c. What is separating these two sides? This is a plus in between, this is a minus. These two sides are conjugate surds. One is the opposite of the other. Like we said here, root of 3 plus 7 and root of 3 minus 7. These two are conjugate surds. It's the same with these mixed surds. 4 root of 6 minus 3 root of 2. Then we have 4 root of 6 plus 3 root of 2. These two are conjugate surds. They are the same figures. The only difference is that one is a plus, the other is a minus. One is a plus, the other is a minus. Now, what happens when we multiply these two conjugate surds? When we multiply these two conjugate surds, we get what we call a rational number. Now, a rational number, remember we said, that is a number that can be expressed in form of a fraction. So this is where the term rationalizing comes from. So when we are rationalizing a surd, we actually multiply it with its conjugate. When we multiply it with its conjugate, then that process of doing so is what we call rationalizing. So right here we are having two surds. We are having this original surd, which is root of 2 plus 3. That is its surd, the surd. And we are being required to rationalize this surd. So now in rationalizing its surd, we are supposed to multiply it with its conjugate. And its conjugate is going to be root of 2 minus 3. So it's minus. That's the only difference. So it means we're going to multiply this bracket by that bracket. So it is going to be root of 2 times this, which is root times that. Then we have plus 3, plus root of 3, which is that. Root of 3 multiplied by that whole second bracket, which is this. Definitely here we shall keep opening brackets. Root of 2 times root of 2, which is this. Then plus root of 2 times negative 3, which is that. Then we have plus root of 3 times root of 2, which is that. Then we have times root of 3 times negative root of 3, which is that. Then the rest is arithmetic. Root of 2 times 2 is root of 4. Then positive root of 2 minus times negative root of 3. Positive and negative gives us a negative, so it's going to be a negative 2 times 3, which is 6. Then we have root of 3 times root of 2. They are both positive, so it's going to be positive root of 6, then minus root of 9. Because positive root 3 times negative root 3, a negative times a positive gives us a negative, so negative root of 9. And of course this and that will die, because negative root 6 plus root 6 gives you 0, so this cancel out. You remain with root of 4, which is 2, minus root of 9, which is 3. You end up with your answer being negative 1. So now negative 1 is a rational number, and so this means that you have rationalized this surd. Now you realize that from our previous example, when we were rationalizing surds, this process of multiplying a surd by its conjugate gives us what we call a product of two squares. And if you go ahead and substitute this direct, we shall get our answer direct without having to go through a lot of steps. For example, when we get this term and we multiply it by its conjugate, we create this kind of identity, and this kind of identity is what is the difference of two squares. And when two squares are multiplied, the difference of two squared is the same as a squared minus b squared. In this case, it is root of 2 minus b squared, which is root of 3, which gave us 2 minus 3, which is negative 1. So let's look at these examples. We are being required to rationalize this. Now, rationalizing this means that we are supposed to multiply it with its conjugate. So multiplying that with its conjugate is as simple as doing it like this. So this is then what we are supposed to. So we multiply this with its conjugate, which is going to be 7 root of 6 plus 9 root of 3. So when you open this bracket, it's going to be 7 root of 6 into multiplied by that, which is 7 root of 6 plus 9 root of 3, then minus 9 root of 3. Multiply that by this whole thing, which is 7 root of 6 plus 9 root of 3. So we go ahead and open brackets. When you open brackets, we multiply the whole numbers alone first. 7 times 7 is 49, times 6 times 6 is root of 36 times root of 36. Then we have this times that. So we have 7 times 9. 7 times 9 is going to be 63, so it's going to be plus 63. Then we have 6 times 3, which is 18 times root of 18. Then right here we have 9 times 7, negative 9 times 7, 9 times 7. 9 times 7 we are having 63, so it's minus 63. 3 times 6 is 18 times root of 18. Then we have negative 9 times this. So negative 9 root 3 times that is going to be negative 9 times that is going to give us minus 81, and into the square root of 3 times 3, which is 9. And definitely there, if you realize this and that are going to cancel, because positive 63 root of 18 minus 63 root of 18 is 0, so this will cancel with that. You remain with 49 times root of 36, which is 6. Then here minus 81 times root of 9, which is 3. 49 times 6, our answer here is 51. So let's do this. Now in this number I'm going to rationalize this number, but I'm going to use difference of two squares instead. So rationalizing this number, we can multiply it. We first of all multiply it using its conjugate. So it's going to be 3 plus 2 times root of 3. Multiply it by its conjugate. Its conjugate is going to be 3 minus 2 root 3. Now, using the difference of two squares, which is this, our value of A is 3, our value of B is that. So this is the same as saying 3 squared minus 2 root 3 squared. And definitely that's going to become 3 squared is 9 minus 2 root 3. This is going to be 2 times 2, which is 4, times root 3 is 3. And we end up with 9 minus 4 times 3, which is 12. And our answer is going to be negative 3. And this is how we rationalize the denominator. Up next, we are going to look into detail on how exactly we rationalize the denominator of a function. Today we get to learn how to rationalize the denominator. This is Kisembo Academy, and thanks for tuning in. Now, rationalizing the denominator simply means that when given a surd in a fraction form, such as 1 over root of 3, as you're seeing on your screen, or a surd like this one, 4 over 2 minus 4 root 3, and so forth, we can make the denominator a rational number. Now, the process of making this denominator a rational number is what we are calling rationalizing the denominator. And just like we've been exploring in our previous videos, we rationalize this denominator by multiplying it by its conjugate. So for example, if we want to rationalize this denominator, we are going to multiply this by its conjugate, and we are going to do the same to the numerator. Now, sometimes we have numbers that are having a single surd in the denominator. How do we rationalize those ones? So numbers or expressions that are having one-term expressions in the denominator, such as these ones, are rationalized by multiplying it by an equal surd. For example, here, if it is root 3, we are going to multiply it by root 3. So it means that here, if I'm to rationalize this, I'm going to multiply this by root 3 times by root 3. And definitely 1 times root 3 will remain. Root 3, divide that by root 3 times root 3 will give us 3. And that's the answer. We have rationalized the denominator. Remember that from this, that when we multiply a number, root of a times root of a, we get a. Therefore, root of 3 times root of 3 should give us 3. When you multiply the root of a number twice, we get that very number. So let's try out this. Rationalizing this denominator. So we multiply, if it's a one-term expression in the denominator, we multiply it by that very surd. And we do the same up here. So 1 times root of 3 is going to become root of 3, divide that by root 3 times root 3 gives us 3. And that's our answer. Here, it's one-term expression in the denominator, so we multiply this by 2 root of 5 times 2 root of 5, up and down. So this times that is giving you 8 times 2, which is 16. Root of 5, divide that by. So now this is 2 times 2, which is going to be 4. Then we have root of 5 times root of 5, which is giving us times 5. And of course the answer here is going to be 16 root of 5 over 4 times 5, which is 20. This can be simplified further by 4. Here we get 4 by 4, we shall get 5, and our answer will be 4 times the square root of 5 over 5 as our answer. Then we have this number. It is having that in the denominator. So to rationalize this number, rationalizing this surd, it's going to become, we're supposed to multiply the denominator by its conjugate, since in this case here it is not exactly a one-term expression. Since it's not a one-term expression, we're going to multiply this by its conjugate. When we multiply this by its conjugate, we do this both in the denominator and the numerator. So this is going to become 3 over 3 minus root of 5. Multiply this by its conjugate, which is 3 plus root of 5. Do the same up, 3 plus root of 5. This is going to become, we open brackets, 3 times 3 is 9, then 3 times root of 5 is plus 3 root of 5. Divide that by, if you look at this 2 below, this is difference of two squares. So this times that is giving us a squared minus b squared. So a squared is 3 squared minus b squared is root of 5 squared. So our answer is going to be 9 plus 3 times the square root of 5. Divide that by 3 squared is 9 minus root of 5 is 5. And the answer here is going to be 9 plus 3 times square root of 5. Divide that by 5 by 3. So the answer here is going to be by 3 ones by 3, 3, and here 1. So we end up with 3 plus root of 5. So rationalize the denominator in that expression and give your answer in the form of a plus root of b. You can go ahead and do that number. The answers are... This brings us to the end of this video. Thanks for tuning in. I encourage you to subscribe to this channel for more videos. Please don't forget to hit that like button and share this playlist with your friends. For Kisembo Academy, this is Anodranga Koromia.